Hi guys, today we're going to talk about the least squares regression line, how to calculate that. That's what you formerly have known as the line of best fit. We're going to talk about residuals, interpreting slope, and y-intercept, among some other things. I'll try to break this up into different parts. So this one is officially part one. Let's get going. The following data gives the weight in pounds and cost in dollars of a sample of 11 stand mixers. We have our data right there below. We want to think about now, what is the explanatory variable? What is the response? It's a quick review, but will also help us if we would need to graph, okay? Well, with the weight of a mixer, okay, so one of those mixers that like stands up and you put, and it's electric and it mixes, like if you're making chocolate chip cookies, it will mix it up for you. Do you think the weight influences the cost, or the cost is going to influence the weight? Hopefully you're thinking the weight influences the cost. That's so if I have a lighter one compared to a heavier one, that might change the cost of how much that will be. That would mean the weight is the explanatory variable. That would be our X, and the cost is our Y. And that is important as we start to interpret the slope and the y-intercept as well. Very important. What I want you to do right now is I want you to go ahead and I want you to pause the video. I already taught you how to put it in your L1 and L2. Go ahead, open up your calculator right now. Go into Stat, Edit. You have your L1 and L2. I want you to practice just entering. L1 is going to be that explanatory variable, the weight. L2 is going to be the response variable, the cost. Pause the video and do that right now. Okay, hopefully you are back now. Okay, now what we want to do is we want to run our ln reg A plus BX. So to remind you how to do that, we hit Stat. We arrow over to Calc, and we use this number 8. We have L1, L2, and we calculate. Those of you, I'm not sure if I addressed on the old calculators, forgive me if I didn't. Those of you with the old calculators, you can just go ahead and hit enter one more time. And we see this screen, okay? And I'm going to be fancy and I'm going to pull it over here. Okay, what our goal today is, we've already talked about the correlation coefficient, so you can see we have a stronger relationship. Okay, it's positive, linear relationship between weight and cost of stand mixers. But today we want to focus on that regression line. So if I would plot it, right, and I would draw that line with about half the dots above and half the dots below, what would that equation of that line be? And you can see they give us this, okay? Y equals A plus BX. In the calculator, the A is our y-intercept. The B is our slope, okay? I don't care about R squared or R right now. I'm not asking about that. We've already had a lesson about R, and we'll learn R squared later. So you can see now, the way we write it is not going to be Y equals A plus BX. It's going to be Y hat. And the reason that is, you guys, is because we're using that line to predict the price. I have lots of observations. Those observations help me build this line, okay? And we can actually see it. I'll show it to you in a second, okay? But let's actually fill that out now. Now, I did say y hat equals A plus B. Our variables must be labeled. What does that mean, okay? So you can see here, we have A is negative 20.71 and B is 12.53. When I plug A and B in, I don't want to just plug A and B in. I want to label what these variables are. So what is Y and what is X? Well, first of all, let's get to why do we come up with a regression line, a least squares regression line? We come up with that because we want to use it for prediction. Let's say Mr. Opal and I want to go buy a mixer. And I say, I think I want a 15-pound mixer, Mr. Opal. And he's like, well, how much is that going to cost us? And I could put it into my equation and predict the price of that mixer. We use least squares regression lines for prediction. I want to label this though, because I want it more in context. So Y is not only Y is my response variable. Y is my price. And I put this line over there because again, it is not the actual price that it will be. It is the predicted price. We have our y-intercept, our A, so I plugged that in right there. And then our B, 12.53. Times X, well, X is no longer X. X is our explanatory variable. That's our weight. Okay, that's our weight. So I tell Mr. Opal, hey, yeah, it weighs 15 pounds. I can plug in 15 right here, run it through my equation right there, and I can tell him the predicted price. Okay, let's think. What have we learned so far? We have some data. We can graph it on a calculator to make sure it's linear. I'm not going to do that right now. But then what we can do is we can come up with a line, okay? We can come up with a line for prediction. We have our y-intercept, we have our slope, okay? We run it through linreg a plus bx and we get it just like this. Now some people get very, I don't know, they get very techie and they like to stick with x's and y's. It is fine with me if you do this. Y hat is equal to negative 20.71 plus 12.53x. But then you have to, on the side, rewrite out that x is equal to weight and y hat is equal to the predicted cost. If you do not do this, you guys, either one of these part where you have it in context, you'll be docked. Okay, you will be docked. Let me know, rewind and quickly show you how to graph this on the calculator so you can see. So I have all of my data, right, in my L1 and my L2. Now what I can do is I can go into second y equals. I can hit enter on plot 1. I'm going to go over, and this one right here is my scatter plot. So I'm going to hit enter. Then I'm going to hit zoom and 9 for zoom stat. And you can see, yeah, I do have a pretty linear graph right now. Now what I can do is I can put an equation in it. Now watch, I'm going to do that for you now as well. People with the old calculators, we might have to have a Google Meet just to like play around with how to put the old equation in. Otherwise it won't be exact, not the end of the world. But if you're just curious, okay? So I want to go to stat. I want to calculate my linreg number 8. So I got my linreg a plus bx, right? I have that. Now what I actually want to do is I want to go ahead and I want to store the regression equation. How I do that is I want to go to vars. I want to go to yvars. I want to hit enter on function and I have y1. What that's going to do now is it's going to take that regression equation and store it in y1 for us. Now if I go back and I look at my graph, it plots that line of best fit for us. You can see we have about half the points above and about half the points below. I'm going to go ahead and use my fanciness and pull that over. Okay, so you should feel comfortable now using your graphing calculator to calculate the least squares regression line. But you were given a set of data there. You were given a set of data. What if you're not given a set of data? What if you're only given statistics? What do I mean by that? Writing an equation of a line when they do not give you a table, they don't give you data, they give you statistics. Once upon a time, there was a number 48 that was modeled after this. Let's go through this now. The number of miles in thousands for the 11 used Hondas have a mean of 50.5 and a standard deviation of 19.3. The asking prices had a mean of 14,425 and a standard deviation of 1,899. The correlation for these variables is R is equal to negative 0.874. Find the equation of the least squares regression line and explain what change in price we would expect for each additional 19.3 thousand miles. Okay, notice what you are given. You are given what the X variable is. Okay, the mean for the X variable. You are given the standard deviation for the X variable. You're given the mean for the Y variable, the standard deviation for the Y variable, and you're given the correlation coefficient for both of them. Now, maybe you're thinking, oh, what is the X? What is the Y? I don't know. Take a deep breath. What are we talking about? We're talking about the number of miles that were driven as well as the price. What do you think is going to be the explanatory variable? What will influence the response? Will the number of miles on a car influence the price? Or will a price influence how many miles are on the car? I think the number of miles on a car, are going to influence the price. A car with not very many miles might be more expensive, but a car with a lot of miles will probably not as expensive because it's a little bit more run down per se. Okay, so we know then the average mean would be for the X variable is going to be the average miles, okay? The average miles. So right here, 50.5, that is our X bar. Standard deviation would be 19.3 then. Standard deviation of X. The asking prices, this is the cost now. That's going to be the average. That's our Y. That's our response. The cost. That's right here. This is our Y bar. With a standard deviation right here of 1,899. S of Y, I said. And then we have R here as well. That's the first thing we want to identify, you guys. Step one. What was our X and what was our Y? We established that already. X was the number of miles driven. Y hat is going to be the predicted price. We then went ahead and we labeled what our X our bar was, our SX, our Y bar, our SY, and our R. X bar, average of X, Y bar, average of Y. What are we doing again? We're writing an equation of a line when they don't give us a table. Okay, next, guys, step two. Oh, I lost what I had there. Give me 1 second. Okay, I'm back. Things did not save on me, right? So I had to re-put some things in. Okay, so what have we done? Just to recap, we figured out what the explanatory variable is, what the response is, okay? And then from there, we highlighted the mean of X, okay? Standard deviation of X, which would be your explanatory variable. Mean of Y right here, okay? Which is your price, standard deviation of Y, and then your correlation coefficient. So we identified everything that was given to us. The next thing that we want to do is we want to look at our formula sheet, okay? So I can actually go to my formula sheet and you can look right here. They give us the linear regression, the least squares regression line right here. Here they give us the slope, and then here they give us the equation to solve for A, that y-intercept, okay, which is really, we're going to use some to go back to algebra 1. Could you use point slope formula if you wanted? Sure, you can do that as well. Doesn't matter. I'm going to just do it based off what they have here that they've given us. Okay, so step one, identify our variables. Step two, and what's been given to us. Step two, we're going to use that formula that I gave us right there. So you can see they gave us the regression line. We're going to find the slope first, okay? In order to find that slope, okay, I'm going to plug in what I know. I know the correlation coefficient, negative 0.874. So I plugged that in for R. That's right here. I know the standard deviation of Y, okay? 1,899. That's right here. I also know the standard deviation of X, 19.3. I plug that in my calculator and I get negative 85.996. That's the value of my slope, okay? The next thing I'm going to do, so that was that equation right there on your formula sheet. The next thing I'm going to do is I'm going to go up on my formula sheet and I can see, hey, I all know my slope right now. I also know my average of X and my average of Y. I'm going to plug that in and I'm going to solve for A. That's going to give me my y-intercept now for my regression line. So step three, we're going to use this formula right here to find that y-intercept. I know Y bar. Y bar is is 14,425. Okay, 14,425. I do not know my y-intercept yet. I do know my slope, and I do know my average for X, my X bar. What I'm going to do now is I'm going to use algebra to solve for A. So I'm going to multiply this together and then add it to 14,425 to get 18,767.798. Okay, step one, okay, recap, identify my variables, identify what's been given to me. Step two, use this formula for slope to figure out your slope. Step three, plug in Y bar. We don't know A. We know B, we know X bar, solve for A. That's your y-intercept. We now have our slope, we have our y-intercept, and we can go ahead and we can write the regression line, the least squares regression line. Y hat equals A plus BX, which is right there. Notice I also put in the variables because that is what is expected of you. Okay, part 1 is done, you guys. We know how to write a least squares regression line when we are given statistics like this example or data like this example.